Good morning or good afternoon. My name is Rafed Fareed. My student number is 101-205-956. So let's begin. The first question, it's asking us to create a kernel to detect all the 45-degree angle lines. So here we have, this can be any name, it doesn't matter what the name is. But now when you create a kernel in NPRA, you make everything -2 except bottom left, middle, and top right. That indicates a 45-degree angle. Now in here, come to the kernel. You wanna plug this in over here for the kernel. And in here, this is the original image. So the original image is gonna be multiplied by this kernel. Then we're gonna plot it, and as you can see, all the 45-degree angles are being shown here. Number 01B, it's asking us to do the same thing, except this time we need to detect 135-degree angles. So again, everything is -1 except bottom right, middle, and top left. This is how you know if something is a 135-degree angle. Again, plug this in for the kernel, multiplied by the this will do everything pre-built. So the original image is going to be multiplied by the kernel, and these are all the 135-degree lines. So now let's see, apply the following kernel to the image and plot output. This is the same as the previous questions, except they already gave us a kernel. They just want us to multiply it to the image. So you just have to simply plug it into the kernel. Kernel is equal to as kernel 1, and this is the image you get. Same thing for 2, plug it into the kernel. This is also what you get. And number 3, same thing. And this is what you get. So let's see here. I'm just trying to look for the question. So these questions I should answer. Did the network present signs of overfitting? If so, in which epoch? And here I said after 10 epochs the model started overfitting. I just simply eyeballed it. Like I said around here, you know, this is when it starts to overfit because the gap is way too big and it's not showing any real progress. Training is starting to overfit and the validation has no progress after 10 epochs. Write down how many layers this model has and identify their types. So this model has 4 layers. The layers are the conv 2D, max boolean 2D, there was 1 hidden layer and 1 output layer. And in here I just have a note. I won't consider flatten to be a layer because all it's doing is reducing the number of the model data from 255 to numbers between 0 and 1. And what I'm talking about is where is it? If I can just show you. Right here. See, I know it's a bit confusing because it says layers.flatten, but this I don't really consider it a layer because again all it's doing is taking the number 255 as data and just making it flattened. So instead of 255 it's going to be numbers between 0 and 1, which deep learning prefers more than high numbers, big numbers. Okay, write down this we did. Okay, briefly explain what the purpose of each of those layers are. So conv2d, extract information or features as it's referred to from the image or model, whatever you want to say, by multiplying the matrix by the kernel. So right here, the matrix, I'll just say this is the image, and the kernel, you multiply the image by the kernel to get a new output that either intensifies some features and extracts some features and leaves ones out, Like the first problem we did was we wanted to get 45-degree angle lines. So the kernel was everything is negative except bottom left, middle, and top right to get all the 45-degree angles. Okay, max Boolean 2D. Intensify the features that were found by choosing the max number from the matrix. So the new matrix that you got by multiplying the image by the kernel, you just look for the biggest number, and that's the one that you choose. And all it's doing is basically reducing the conv2d by 2 every time, because you're only choosing one number, the max number out of the set. Hidden layer. Set of parameters with biases and weights that change the possible outcome for the next layer. Okay, and then output layer. This is the final layer with sets, which is a set of possibilities for the most likely answer or target, which is what it's referred to as. So add one more convolutional layer to your model and run it again. So right here I put another convolutional layer. I ran the test again, and this is what you get. And really, if you see the previous chart, previous plot versus this, it's almost similar. Around 10 epochs, it starts to overfit again, and validation stops showing any real progress. Compare the results. The model with more conv2d has less accuracy for validation, but other than that, there is no significant difference. You know, even this less accuracy, like it barely has any less accuracy, so really nothing changed. Add a dropout to your layer model, run it, and compare the results. So whenever you want to add a dropout, you can't add it near the conv2d. Okay, this is getting generalized data, just the lines, curves, and everything. Okay, you want to flatten it, and then right before your hidden layer that has the most parameters is when you want to make a dropout layer. So if we had two hidden layers, just put it for the one that has the most neurons, and then that's gonna give you the best results. Okay, now let's see. This is better, because you know, as you can see, we used to be like down here a bit. Now we're at the 70s, and in here we were at 65, I'd say. So it's a bit of an improvement. Explain with your own words what the purpose of dropout layer is and how it works. Dropout layer helps us with reducing the possibility of overfitting by decreasing how many neurons we have in each hidden layer. Excuse me. Furthermore, taking out neurons from hidden layers will help our model not to be too dependent on certain neurons, therefore reducing overfitting. For this part, it's more of let's say your model starts to develop certain patterns, and your model picks up on them. So what you want to do is take some of those neurons out, and then you can see whether your model is simply memorizing to get the proper target, or if it's actually using, let's say, logic to get the target. So this is why you want to take out neurons. And in this final part, make any modifications. All I did really was, instead of 50% dropout, I put 30% dropout. Let's see the results. It's almost identical, to be honest. Nothing really changed. So I guess for this model, around 70 is where it's best at. That's the most accuracy it's gonna get, at least for me. And that seems to be the end of my presentation. Thank you for listening and have a good day.